Today we will discuss the lecture number 2, and in this lecture we will discuss the acceleration due to gravity. Write down the topic name is uh, acceleration due to gravity. Acceleration due to gravity. Let's suppose this is the earth. On the earth there is an object which have a mass m, and we know that if it have a mass, then mg is the weight force applied on the earth due to the earth. Let's suppose the radius of earth is the r. So we know that the force will be equal to force due to the gravity will be mass into acceleration, mass into acceleration. Okay, so here acceleration due to gravity, we know that acceleration due to gravity we will use uh, g. It is denoted by the g. So here we will use mass m into g. Okay, and force when the particles m particles, a small m particle placed on the earth surface, then the gravitational force between the earth and the small m particle will be the mass of earth into a small m by radius of earth square. Here you will see mm is the cancel out, so you will get the value g m e upon r square. Okay, where r is the radius of earth and me is the mass of earth. Me is the mass of earth, r is the radius of earth, radius of earth, and g is the gravitational constant. And everyone know about the value of mm, mass of the earth. You have idea what is the mass of the earth, what is the radius of the earth, and what is the value of g. When you are putting here, then you will get the value of around 9.8. This is not an exact value, but we get the 9.8 around, and we use 10 for solving the questions in our physics. Okay, so sometimes we use the 9.8 and sometimes we use the 10 also, but we can also change that g value in the form of other, like g, we get the g me by r square. We know that mass of the any body can be written as a density into volume. Okay, so when we are converting that mass into density into volume, so we write 4 by 3 pi r cube. Now we are putting here, then we will get g upon r square and rho 4 by 3 pi r cube. Here this is the cancel out, and we get the next new formula, that is called the g rho 4 by 3 pi r. So here we will write 4 by 3, arrange this 4 by 3 rho g into r is called the g. So there are the two formula. Here we get one formula is called the g me upon r square, and another formula we get 4 by 3 g 4 by 3 pi g rho g into में r. This formula is used when the mass is the same of the body, मतलब mass is the same of the planets, but this formula is used when the planet density is given and radius is given, then second formula we will use. Okay, so write down and then I will give you a important point on the G. So first write and then I will give you. Okay. Now, now we are moving for the important point about the small g. Write down the some important point. Some important point. Some important point about. Some important point about a small g. G. First point is G depends on. G depends on mass, comma, radius, and density of planet, density of planet, where we have find the value of G. Like Earth, you are calculating the G on the planet of the Earth. So you are taking the mass of Earth, radius of Earth, and density of the Earth. But it is, but it is independent of independent of mass, but it is independent of mass, shape, and density of the body, of the body placed on the surface, placed on the surface placed on the surface of the planet, surface of the planet, that means if we have a heavier mass or we have a uh, uh, lighter mass, both have a same value of the G. Okay, so that is same acceleration, same acceleration acceleration acceleration, same acceleration due to earth earth in a light as well as heavier body, heavy body, HEAVY, heavy body. Okay, so G only depends on the planet where we will taking the experiment and which planet we will use for the calculation of G. Like we are using the Earth planets. Here we use the Earth planet, acceleration due to gravity on the Earth. So it depends on the density of Earth. Density of Earth. After that, it depends on the mass of the Earth and radius of the Earth. But when we are using that G value on that any we are taking the any particles, heavy mass or like a light mass, its value is the constant on that particular particular body. Okay, after that we will discuss another important point. Right on second one, greater the value of m by r square, greater the value of m by r square, greater the value of m by r square, or we can say the rho into r, greater will be the value of G, rho into r greater, greater will be, value of, g, for that, planet. Okay. Why I am taking that point? Because here we get the a small g value is the capital G me upon r square. So if the value of me by r square is greater, so g value is the greater. Or we can say the rho and r is the greater, then its value will be the greater. Okay, that's why we are taking that point. Right on the third point. And third point is the acceleration due to gravity is, that means the is is a vector quantity. Okay, vector quantity, because acceleration is the vector quantity, that's why we are taking the vector quantity. And and if any vector quantity, that means it have a direction, so we can say the and direction is its direction is its direction is always towards the, always towards the center of the planet, towards the center of the planet, center of the planet. Okay, next point is the if anyone asks you what is the dimension formula, so you can easily write the dimension formula is the lt minus 2 m0. Okay, next point is the sum value. If anyone asks you a value of the g, so I have already told you 9.8 meter per second square. How do we get that value? When we are putting the value of g, mass of earth and radius of earth square, then you will get the 9.8 meter per second square. And if anyone asks you to write the value in the cgs, so we use the 980 centimeter per second square. Okay, if anyone use in the feet, sometime we will use in the feet, so 32 feet per second square, per second square. These are the three value which is the important for us. One is the CGS units. No, first is the SI unit, second is the CGS unit, and third is the foot FPS units. Okay, FPS. So here we will use the some unit of the G and value of the G. Now next point. Next point is not next is the topic. Write down acceleration due to gravity. Write down acceleration due to gravity. Acceleration due to gravity vary due to due to the due to the following factor. The following due to the following factors means there are the following factors where g value will be the change. Okay, so first factor is here we will take that is called the shape of the earth. Shape of the earth. We know that the earth have a elliptical path, that's why its shape is not same everywhere. pole have pole have a flatted, and equator is the bulged. That's why the value of the g is the changes according to the pole and the equator. So I will take the that point also. And second thing is the when we are moving from the above the earth surface, then its value also change. So height above the earth surface, second factor is the height above the earth surface, above the earth surface, above the earth surface. Third point is the depth below the earth surface. When we are moving inside the earth, then its value will be the change. So depth below the earth surface. Okay. And fourth one is we know that the earth is rotating with the some uh, angular speed. So axial rotation, of the earth, axial rotation of the earth, of the earth. So there are the four factors here we will discuss. First is called the shape of the earth. Second one is called the height above the earth's surface, and third one is we will discuss the depth below the earth's surface. Fourth is the axial rotation of the earth's surface. So these are the fourth factor we will discuss here. So write down the first factor, that is called the variation in g due to the shape of earth. Write down first point here. Write down the first point, that is called the variation in g due to shape of earth, shape of earth. Okay. If anyone asks you why the g value will be the change due to the shape of earth, so everyone know about earth is a elliptical in the shape. Write down earth is earth is elliptical, e double l I p t I c l, elliptical in shape, in shape. It is flattened at the pole, we can say the poles. Okay. And bulged, bulged, bulged out, bulged out at the equator, at the equator. Okay. At the equator, the equatorial radius, next point, the equatorial radius is is about 21 kilometer 21 kilometer longer than polar radius, polar radius, polar radius. Okay. Polar radius. Now here we have understand the equatorial radius is the longer than the polar radius. How? Because when we are making the elliptical shape of the earth, when we are making the elliptical shape of the earth, this is called this axis is called the polar axis. Okay, and this is called the equatorial axis. Okay. Okay, so this is the radius of equatorial, RE, and this is the polar radius, we can say. Okay, so here the value of G is called the GE, and here when you are moving from that point, then value of the G is called GP. Okay, this is called the pole point, and this is called the equator point. Equator point. Okay, now we are taking the value of G at equator. When we are writing the value of G at equator, so we can say value of G at equator is the G. Mass of the earth is not changed because this is the planet, but radius of earth is changed, that is called the RE square. Okay, when we are write the value at pole, yeah, polar axis, when we are writing the at the pole, we know that value of GP is equal to mass of earth, G into mass of earth upon RP square. I have already told you capital G is never changed. It is the independent of the shape between, independent of the medium between the them, and it is the universal constant. When we are taking the ratio of that value, GE upon GP, then we will get RP square by RE, because inversely proportional. That's why we are writing this point. Okay, and we know that radius of RE is greater than RP. That's why G at the pole is greater than G at the equator, because it is the inversely proportional. No? Okay, this is the inversely proportional. That's why we are taking the a small g at the pole will be the greater than the equator, and its value, when we are solving that value, then we will get g at the pole is equal to g at the equator plus something is that is called the 0.018. Only this is a very less value, but we are adding that value 0.018 value. Sir, then you have asked me, sir, why we are taking the value of G is the 9.8. This is the average value on the earth surface. Okay, this is taken the average value, means equator, and when we are adding the equator value and the pole value and divided by the 2, then we will get the value of the 9.8, around the 9.8. But if anyone asks you what is the value of G value is the change from the equator to the pole, then we can say that yes. And in equator, when we are moving on the equator to the pole, then G value is increases. Okay, so write on that point, and then we first write that point, write down everything, and then I will move for the next point. Okay, done. So write down some important point here, and then so weight of a body increase, we can say here. So weight of the body, weight means mg, weight of of body weight of body increase as it is taken from equator to the pole. You can say now, from equator to equator to pole. When we are moving from the equator to pole, g value is increased. That's why the weight of the body will be increased. So first variation we will here completed, that is the variation of g due to the shape of the earth. Okay, now we are moving for the second variation, that is called the variation in the g with height from the earth surface. Variation in g, variation in g with height from the earth surface, from the earth surface. Let's suppose that this is the earth surface, this is the earth, okay, and this is the center of the earth, and this is the radius of earth. And now we are moving from the surface of the earth to the h height. This is the from that point to h height. Okay, when we are moving from the h height from the earth surface, then we will get the value of the g will be the change. So we can write here the g dash. Okay, so we know that g on the earth surface is the g me upon r square. When we are finding the value of g dash, so we can write the g me upon me r plus h square. This is the g dash. When we are dividing the both equation, then we will compare the what will be the changes or not changes of the g. So when we are dividing the value of the g dash by me g, so we get the value of g is equal to r square by me r plus h square, because it is the inversely proportional. So here we will write. Now we are taking the small r value is the r plus h. Okay, we are using the small r value. So we get the value of g dash. Here we will get the value of g dash is equal to, first we are writing the g r square by me r plus h square. And now we will convert that and we get r square by me small r square. Okay, here you see when we increase the r value, when we increase the small r value, the value of g will be the decrease. The value of g will be decreased. So when we are moving from the earth surface, so we get the value of g decreases. We can say g dash is inversely proportional to the r square. So above the earth surface, above that we can say right above the earth surface. Wait 1 minute. Above the earth surface of above the surface of earth. Okay, above the surface of earth, above the surface of earth, the value of g decreases. The value of g decreases because g dash is inversely, oh, all right, already I have right, but okay, koi baat, don't worry. G dash is the first point is the important, and the second point is the, if r value is the infinity, let's suppose the r is the very long distance, then g dash value will be the 0. So we can say that when we are moving from the infinite distance from the earth surface, the g value will be the 0. So zero gravitation. Okay, third point is the here important, that is called the if if h value is very less than the r value. Okay, if the h value is the very less than the r value, so here we can say the g is equal to g r square by me r plus h, both are the squaring. Okay, so first of all we have compared to the h is less than r. So here we have need to convert that particular things into the another things that like this g into may we can write the 1 upon r plus h upon r square. I am inverse that r square is the y inverse because we have need to compare h is less than the r. So first of all make the relation of h into the r. Now we get the g is equal to g dash is equal to g into 1 plus 1 by, here we have writing na 1 by r plus h by r square. Okay, so here I can also write g is equal to 1 plus 1 by 1 plus h by r square. When we are dividing the r value, then this r will be the cancel out and we will get the h r square. So when we are converting that value, so we get here 1 1 minute wait. Okay, ठीक. 1 plus h by r power minus 2. And h by r is the very less value because very less than the 1 because h is the less than r value. Okay, so where we can say we can use the binomial expansion approximately and we will get 1 minus we apply that value 2h by r and minus is plus minus converted into. So here we get g dash value is uh, if h is the less than the very less than the r value, then we will get the g dash value is the g into 1 minus 2h by r. Okay, 2h by r. Okay, so we can say here, absolute, if anyone asks you absolute decrease in g value, that is the delta g. So we can say that g minus g dash initial final minus initial, yeah, g minus g dash. So we get when we are putting here value, so we get directly 2 h g by r. Okay, when you are putting the value of g dash here, we get that value. This is called the absolute value. But if anyone asks you the fractional value, fractional decrease in the value, fractional decrease, so you can, you know about the fractional decrease delta g by z. So we get the 2h by r because g is the cancel out here, g is cancel delta g value this upon divided by the g, so 2h by r. If anyone asks you percentage decrease, percentage decrease, so you can write the delta g by g into 100, so you get the 2h by r into 100. So take the screenshot first and then I will. So next value is the variation of g with depth. Next is the variation of g. Write down variation of g with depth. With depth. So here we get when we are moving inside the earth surface. Let's suppose this is the earth, and when we are moving the inside the earth surface from the surface of the earth, let's suppose the d inside this. So here we get the value of g dash, and on the earth surface we get the value of g. So we know that the g is equal to g me upon r square. But when we are moving inside the earth surface, then our r value, let's suppose the r value will be the decreases r minus d. Okay, r minus d. And another value also know g dash is equal to 4 by 3 pi rho into me g into me r. Okay, this is the two value of the g on the earth surface. We know that we have calculated. Now we have using that formula for calculation of the g dash. So where we write 4 by 3 pi rho into g, and r is the decreases because we are moving inside the earth, so r minus d, we can use the r minus d. So here we will get, when we are putting the value of g from the taking the r common, when we are taking the r common from that value, so we get rho g into r into 1 minus d by r. Okay, this value is the g. So here we can write the g dash is equal to g 1 minus d by r. Okay, this is the g dash value we will get here. So here also we see, when we are moving inside the, yeah, when we are moving below the surface of the earth, we get the g value will be the decreases. So we can write here, uh, here we can write first point. What will we write? First point, can you tell me? First point is the g decreases. We can say the
Since
first
G
point is
dash
the,
is direct.
okay, d decrease ongoing below the below the surface of below the surface of the earth, surface of the earth. Okay, so why? Because g dash is directly proportional to r minus d distance. Okay, so d increase, when the d increase, d g dash will be the decrease. Okay, second point here I have give you, uh, at the center, at the center of earth, when anyone asks you, okay, what is the g value at the center of earth, so we can say r is equal to g, r is equal to d, that means g dash is equal to 0. So at the center of the earth is g is equal to 0, and when we are moving for the infinite distance from the earth, that's also the g dash value is the 0. So in the both cases the g dash value is the 0. So acceleration, if anyone asks you what is the acceleration at the center of the earth, so you can say 0. Okay. Third point, we can write the decrease in the value of g with depth. If the here we have see the value of g is decreases. So anyone ask you about absolute, okay, absolute decrease. If anyone asks you what is the absolute decrease, so we can write the delta g, and delta g is equal to g minus g dash when we are getting the value of a small d g by r. Okay, if anyone asks you, this is the a point, and b point, fractional decrease. If anyone asks you fractional decrease, so what can we use? Delta g by g, that means d by r. Okay. If anyone asks you, C point is the percentage decrease. What is the value of the percentage decrease? That means the delta g by g multiply 100. That means the d by r into 100. Okay. So this is the our formula for variation of the g in the depth, depth, and we can say the below the surface of earth. Here one thing you observe, here one thing you observe the rate of decrease of gravity outside the earth, the earth H is less than R, or is double, double, double to that of inside the earth. Why I am telling you that point? Because we know outside the earth fractional change is the fractional change of the g is the 2h by r, but inside the earth is fractional change is d by r, so two times we can say the double. So that's why we are taking here the that important point, because sometimes it will comes in the exam. Okay, so write down first and then I will move for the next point. Okay, this is the point here. You have already write the previous slide or not? Okay, so next point is the variation of g due to the rotation of earth. Next point is variation of g variation of g due to rotation of earth. Rotation of earth. Everyone know earth is rotated about the some angular speed. So first of all, write down the some point. The earth rotates. The earth rotates. The earth rotates a body placed on the earth, placed on it surface on its surface, place on the earth surface, a place on its surface, move move along the circular path, along the circular path, and and hence experiences centripetal force, centri centrifugal force, not a centripetal force, because we are observing that is called the centrifugal force. Both are the same, but depends on the observer. So centrifugal force due to due to it the apparent weight of the body decreases. The apparent weight of the body decreases. Okay, that centripetal force will be change the value of g. Okay, due to the centrifugal force the value of g will be decreased. How this decrease? Just I give you a example and then you understand easy way. Let's suppose this is the earth and it will be rotated with omega. Let's suppose it will be rotated with omega, and there is a mass which is present on the earth surface here. Okay, there is a mass which present on the earth surface here. So the mg will be applied. Mg will be applied in the toward the center of the earth. Everyone know that is the toward the center of the earth, and a centrifugal force which is the outside to the sphere, circular motion. And let's suppose if the omega if the earth is rotated with the omega, then that mass will be rotated about that circular path. So it have a radius, let's suppose the r radius, and this is the r radius of the r radius of the earth, and this is called the angle lambda. We are taking the lambda value, just taking another value of the theta. Okay, lambda. So what will be the right here? Here we can say centrifugal force is the m omega square into r. Okay, and we know that the relation between the r and m, the small r is called the r cos lambda. We are taking the value of component of a capital R in the form of the small r. So where we will get the r, small r is equal to r cos lambda. So now if anyone asks you what is the resultant force, so we can say the resultant force is called the mg dash, because the g value is the changes. So we can write the mg dash is equal to mg square plus fc square plus 2 times of fcmg into cos lambda under root. Okay, under root of the value cos lambda. We can write the cos lambda or angle between the mg and fc. Okay, this is the angle between the mg and fc. That means 180 minus lambda. Okay, so when we are solving that all particular value and putting the value of the fc is equal to m omega square r cos lambda. Now then we will get, when we are solving that value in this, when we are putting the fc value in this and then we are solving, then we will get the directly I have written, because there is no need to know about the exact value how to we calculate. If you have a no, so you can put here and then you will get the value. Okay, the g dash value is the, directly we get g dash is equal to g minus omega square r into cos square lambda. This is the important for us. Okay. Okay, write on fast and then I will move for the next point. Write fast because you are taking this. Okay. So now here we see the lambda value. That lambda is the angle between the mg and the centrifugal force. So it value will be the change, because when we are moving the on at the pole, the fc value is here and mg value is here. So at the pole it will the lambda value is the 90-degree, and when we are moving at the equator, then fc value is downward, and fc value and mg both are in the opposite direction, this and this. So we can say the lambda is a 0 or 180-degree. So here we will take first point, that is the at pole. When we are taking the pole, lambda is equal to 90-degree. When we are taking the pole, then lambda is equal to 90-degree. When we are putting the lambda is equal to 90-degree, then we will get the g value at the pole is the g minus omega square r into cos 90-degree square. That means we get the value of the g. So at the pole, when earth is rotated, then g value is the g. So there is no effect at the pole. We can say that there is no effect of rotational motion at the earth, of the earth on the value of g at the pole. No effect. No effect. Directly we can write the no effect. Okay, when we are moving at the equator, Yeah, when we are going to the equator, then what happens? The lambda value is the 0. That means g at the equator, we get the g minus omega square r cos square 0. That means we get the value of g omega square r at equator. Okay. So we can say the value of g it changes at the equator and its value will be the decreases. Okay. If anyone asks you, third point here I have given, anyone asks you g at pole minus g at equator, so we can say directly it value is the omega square r because g is the cancel out. This g and this g is the cancel out, minus minus plus, so we get the omega square r value. If ask you a force, if anyone asks you the what is the force, yeah, what is the increase in the weight of the body, if anyone asks you what is the increase in weight of the body of the body from pole to the equator, so we can say the mass into gp minus g, that means the m omega square r. Okay, so write down. Wait 1 minute, wait, another things I have give and then you will write. Okay, so we can write the third point, weightless weightlessness. Okay, weightlessness due to due to rotation rotation of earth. If anyone asks you कि when you are feel weightless condition, okay, so we can say the g dash is equal to g minus omega square r here, omega square r cos square lambda. Here g dash will be the 0, then we will consider the weightless condition because g is not 0, g dash is the 0. So here we will get the g, and let's suppose कि we are presenting at the equator. Let's suppose, so lambda is the 0 degree. This is the one case when we are at the equator. Okay, so g minus omega square r, this is the value of the 1, so we get the g is equal to omega square r. So we can say the g by r under root is equal to omega. Omega is equal to under root g by r, and 2 pi by t, we know that the omega is equal to 2 pi by t, so we can get the time period where weightless condition will be the comes. So here we can say t is equal to 2 pi under root r by g. Okay, when this is the radius of earth, we can say the radius of earth. When we are putting the value of the radius of earth, you know what is the radius of earth? 64,000 kilometer is the radius of earth. When we are putting the radius of earth 6400 kilometers, so we have need to convert into the meter, and we also know g value is the 10 meter per second square. Then when we are putting the value of this, then we get the value of omega as well as we get the value of time period. So when we are putting the value of this, time period is equal to 2 pi, oh wait 1 minute, 2 pi under root r by g, that means 6400 into 10 to the power 3 by 10. Here the cancel out and we get the 2 pi into 8 and 10 to the power 2. Okay, so 1600 pi is the time period. This is in the second. Okay, when you are getting the value in the hours, then we have need to divide the we had need to divide the value with the 60, then we will get around the 1.4 hours. Okay, so we can say here At the equator, time period difference is the 1.4 hour as compared to the pole. So write down the everything and then I will give you a some note point and then we move. Some students is not come. Here we have seen due to the earth surface, G value is Gp is equal to Ge plus 0.018. It is the comes from the first variation. Okay, 0.018 is come for the first variation, and after the rotation of the earth, Gp will be get the Ge plus omega square r at the equator. When we are talking the equator, when we are putting the omega square r value, then we get the value about 0.034. So if we are adding the both equation, when we are adding the this value in the that value, then we get the original value of Gp is equal to Ge plus 0.052 meter per second square. The total variation of the G from the pole to the equator is the G is equal to 0.052 meter per second square. Write down fast and then you have completed the theory parts. Tomorrow I will discuss the question based on that DPP. Okay, so write down fast.